Hello friends, I am Aryan Gurud, working as Assistant Professor in Survey Institute of Technology, College of Engineering. This is module number 5 of surveying. In the previous lecture, we have seen latitude and departure as a consecutive coordinates, and whenever we are having the line lying in the first quadrant, then the latitude is positive and departure is negative. And when we are going to have the line lying in the second quadrant, then the latitude is negative and departure is positive. Similarly, if the line is lying in the third quadrant, then both the latitude and departure they are negative, whereas if the line is lying in the fourth quadrant, then the latitude is positive and departure is negative. So whenever we are going to calculate the latitude is calculated as L cos theta, whereas departure is calculated as L sin theta, where L is the length of a line and theta is the reduced bearing of a line. Similarly, the latitude and departure of lines are expressed in the following ways. One is northing. Northing is a latitude towards the north and it is always positive, and southing is a latitude towards south and therefore it is negative. Similarly, easting is a departure of a line measured towards east, therefore it is positive, and westing is a departure measured towards west, therefore it is minus d. So in this slide we are going to see the consecutive coordinates. Generally, when the length of a line is known and reduced bearing of a line is known, then it is possible to calculate the consecutive coordinates. When the line is lying in the first quadrant, let us say n theta e, then the latitude is plus L cos theta and departure is L sin theta. Similarly, if the line BC is in the second quadrant, then the reduced bearing of line is S theta e. Therefore, in that particular case, the latitude is minus L cos theta and departure is plus L sin theta. Similarly, if the line lying in the third quadrant is say CD, then the reduced bearing of line is S theta W. Therefore, latitude equal to minus L cos theta and departure equal to minus L sin theta. Similarly, if the line is lying in the fourth quadrant, then the reduced bearing of line is N theta W. Then the latitude is plus L cos theta and departure equal to minus L sin theta. And therefore, when we consider the closed towers, so closed towers is nothing but it is a series of connected line, and the starting point and end point they are going to meet. So therefore, here the point is A. So at point A, the towers is going to close. So therefore, whenever we are having a closed towers, then the algebraic sum of latitude must be equal to 0 and algebraic sum of departure must be equal to 0. So these are the checks to be applied for the closed towers. Then we will see how to write the consecutive coordinates in the form of northing, southing, easting and westing. So we will consider the same closed towers. Let us say a line is AB and having the reduced bearing n theta e. Then the latitude of a line is plus, therefore the latitude we are going to enter in the northing column, whereas easting in the first quadrant the departure is positive, therefore we are going to enter departure, that is L sin theta, in the easting column. Similarly, if the line is say BC and is lying in the second quadrant, that is S theta e, then since the latitude is measured towards south, therefore we are going to enter the latitude of line BC in the southing column. Similarly, if I consider the departure of line AB, since that particular departure is measured towards east, therefore I am going to enter the departure, that is L sin theta, in the easting column. Similarly, when I consider the third line, that is line CD having the reduced bearing S theta W, then in the third quadrant the southing, the latitude and departure both are negative, therefore I have to enter the value of latitude in the southing column and value of departure in the westing column. Therefore, I will write L cos theta in the southing and L sin theta in the westing. Similarly, if I consider the next line, say DA, having the reduced bearing n theta W, then the latitude of the line is L cos theta because it is measured towards north and it is always positive. Therefore, I have to enter in the northing column. Similarly, if I consider the departure of line DA, then L sin theta will be measured towards west. Therefore, I have to enter in the westing column. So similarly, when I consider these individual northing, southing, easting, westing coordinates, then I have to consider the check, that is sum of northing equal to sum of southing. Similarly, sum of easting equal to sum of westing. So friends, in this slide we are going to see what is the definition of consecutive coordinate, what is the independent coordinate, and how the Gales table is to be prepared. So the consecutive coordinates are being calculated by making use of latitude and departure of a point with reference to the preceding point. So the consecutive coordinates are the coordinates which are derived or calculated with reference to the preceding point. Similarly, independent coordinate. The coordinate of any point with respect to a common origin are said to be the independent coordinate of that point. The origin may be a station of the survey or point entirely outside the traverse. Consecutive coordinates may be positive or negative depending upon the quadrant in which they lie. In Gales tables, the independent coordinates of all points are made positive by suitably selecting the coordinate of the starting station of the traverse. The coordinate of the starting station, that is origin, are assumed to be some positive values slightly greater than the maximum negative values of the latitude and departure of the concerned traverse. Thus, all the stations will ultimately come to the first quadrant when the coordinate of the traverse station are correlated with the origin by computing the algebraic sum. This method helps to calculate the area of traverse easily by the coordinate method and also simplifies plotting of the traverse. As for example, the coordinate of starting station A are assumed to be plus 150 plus 50. Thus, all the stations are brought to the first quadrant as shown in the table 9.8. So, in this slide we are going to see how to calculate the independent coordinate with a coordinate of starting station assumed to be 150, 50. So, the points is A, B, C, D, A, and the lines are AB, BC, CD, and DA. So, the values of consecutive coordinates are written as 115 and 40, that is the AB may lie in the third quadrant. Similarly, the line BC having values both positive, that is northing and easting, means that particular line lies in the first quadrant. Then plus 80 plus 25, again that particular line lies in the first quadrant, and lastly DA line is going to lie in the fourth quadrant. So the values are directly calculated by making use of L cos theta and L sin theta, where L is the length of line AB and theta is the reduced bearing of line AB. So similarly, L is the length and theta is the reduced bearing are taken for calculating the consecutive coordinates for the line AB, BC, CD and DA respectively. And after recording the values of consecutive coordinates in the respective columns of northing, southing, easting and westing, then the independent coordinates are calculated. Initially, for the point A, the station that is A coordinates are assumed, that is 150 and 50. So since the consecutive coordinate of line AB is 115, that is minus, so therefore this 115 has to be deducted from the northing of independent coordinate for the point A. Therefore 150 minus 115 gives you 35. Similarly, from the easting, that is it is plus 50 and the westing for line AB is minus 40. Therefore 50 minus 40, that is 10. Similarly, starting with 35 and 10, we will consider the northing value and easting value of line BC. So 35 plus 5, it becomes 40, and 10 plus 50, that is 60. Similarly, we are going to calculate the independent coordinate for the line CD. So again, starting with 40 and 60, we will consider 40 plus 80 equal to 120 is the independent coordinate of line CD. Similarly, 60 plus 25 is the independent coordinate for line CD, that is 85. Similarly, 120 plus 30, that is 150, is the independent coordinate of line DA. Similarly, 85 minus 35 is the 50, is the independent coordinate of line DA. Since 150 and 50, these are the coordinates which are assumed, therefore whatever the calculations we are done in this particular table is correct. Therefore, here one thing you are supposed to see that whenever you are going to make the summation of northing column, southing column, easting column and westing column, then they are equal. So therefore, the whatever the check we have applied for calculating the independent coordinates, therefore are correct. Therefore, in this particular case, there is no closing error as such. So the value of closing error is 0, and this is our objective. Why we go for lateral traversing. Then balancing of traverse. In case of closed traverse, the algebraic sum of latitude must be equal to 0 and that of departure must be equal to 0 in ideal condition. In other words, the sum of northing must be equal to that of southing and the sum of easting must be same as that of westing. But in actual practice, some closing error is always found to exist while computing the latitude and departure of the traverse station. The total error in latitude and departure are determined. These errors are then distributed among the traverse stations proportionately according to following rules. First is Bowditch rule. By this rule, the total error in latitude and departure is distributed in proportion to the length of the traverse leg. This is most common method of traverse adjustment. So first we are going to calculate the correction to latitude of any side by making use of Bowditch rule, and the formula is length of that side divided by perimeter multiplied by total error in latitude. Similarly, in order to calculate the correction to departure of any side, we can use the formula that is length of that side divided by perimeter of traverse multiplied by total error in departure. Similarly, the second rule is transit rule. In transit rule, correction to latitude of any side is calculated, and the formula is latitude of that side divided by arithmetic sum of all latitude multiplied by total error in latitude. Similarly, we can calculate the correction to departure of any side, and the formula is the departure of that side divided by arithmetical sum of all departures multiplied by total errors in departure. Then we will consider the third rule, that is the formula is correction to northing of any side is calculated as northing of that side divided by sum of northing multiplied by 1/2 into total error in latitude. Similarly, correction to southing of any side is calculated as southing of that side divided by sum of southing multiplied by 1/2 into total error in latitude. Similarly, correction to easting of any side is calculated as easting of that side divided by sum of easting multiplied by 1/2 into total error in departure. Similarly, correction to westing of any side is calculated as westing of that side divided by sum of westing multiplied by 1/2 into total error in departure. If the error is positive, correction will be negative and vice versa. So in this slide we are going to see how to calculate the correction by making use of Bowditch rule, wherein we are having the columns such as line, length and consecutive coordinates in the form of latitude and departure, and we are trying to calculate the correction by making use of Bowditch rule. And by making use of correction and the values of consecutive coordinate, we are going to calculate what are the values of corrected consecutive coordinates for line AB, BC, CD, DE and EA respectively. So here, first of all, whenever we consider the Bowditch rule, we are supposed to calculate the perimeter. So perimeter is nothing but it is the summation of all the sides of closed traverse. So the perimeter is 346. And then the values of consecutive coordinates, that is in the form of latitude and departure, they are given directly. And when we are going to make a summation, algebraic summation sum of all the latitude, the value is minus 0.355. Similarly, for departure it is plus 0.315, means there is a error. So this is a error, that is 0.355 is the error in the latitude and 0.315 is the error in the departure. So we have to distribute this particular error in the coordinate of AB, BC, CD, DE, EA by making use of Bowditch rule. So the formula is the correction to latitude of AB equal to length of AB divided by perimeter multiplied by total error in the latitude. So total error is minus 0.355. Therefore, since the error is negative, we have to consider the correction positive. So the value is plus 0.072. Similarly, when I consider the next line BC, so BC we have to calculate the correction for latitude. So latitude of line BC divided by perimeter multiplied by total error in latitude. So since again the error is negative, we are going to consider the correction as positive. Similarly for the line CD, so the length of line CD is 43 meter divided by perimeter is 346 and the total error is 0.355. Therefore the correction to latitude of line CD equal to plus 0.044. Similarly for DE, length of line divided by perimeter multiplied by error, so it is 0.038. Similarly for line EA, the length of line EA is 115 and the perimeter is 346 and the total error in the latitude is 0.355. So the correction to the latitude is 0.118. So the total error becomes 0.355. So this way we can distribute the error in the, and accordingly they are written in the correction of latitude column. So 0.072, 0.083, 0.044, 0.038, 0.118. So likewise we are entered in the correction table of latitude. Similarly, now in this slide we are going to see how to calculate the correction for the departure and by making use of Bowditch rule. So the formula is, in order to calculate the correction for line AB, the formula is length of line AB divided by perimeter multiplied by error in departure. So 70 divided by 346 multiplied by 0.315 equal to minus 0.064 because the error is positive, therefore correction is negative. Similarly for line BC, the correction for departure equal to 80 divided by 346 multiplied by minus 0.315 equal to minus 0.073. Similarly for line CD, the length of line CD is 43 and the perimeter is 346 and the error is minus 0.315, therefore the correction is minus 0.039. Similarly for DE, the correction to departure equal to length of line DE is 38 divided by perimeter is 346 multiplied by total error in departure, that is minus 0.315, therefore the correction is minus 0.034. Similarly for EA, it is 115 divided by 346 multiplied by minus 0.315, therefore the correction to departure is minus 0.105. Therefore if you make the summation, it is equal to the total error. In this slide we are going to see how to calculate the correction by making use of third rule, the calculation of correction. So correction to northing of AB equal to 21.5 divided by 135.650 multiplied by 1/2 into 0.355. So therefore it is 0.029. Similarly, correction to southing of BC equal to 80.755 divided by 136.005 multiplied by 1/2 into 0.355 equal to minus 0.106. Similarly, correction to southing of CD equal to southing of that side divided by sum of southing multiplied by 1/2 into total error in latitude. So it is minus 0.053. Similarly, correction to southing of D equal to southing of D divided by sum of southing multiplied by 1/2 into total error in the departure. So it is minus 0.19. Similarly, sum of correction to northing of A equal to 115.150 divided by 135.650 multiplied by 1/2 into total error. So it is plus 0.149. And when you take the summation should be equal to 0. Similarly, correction have to be calculated for departure also. For line AB, for line BC, for line CD, for line DE and for line EA, and the values of correction for line AB equal to 0.146, correction to westing of BC equal to plus 0.012. Similarly, for correction to easting of CD equal to minus 0.030, correction to easting of D equal to minus 0.078, and correction to the easting of E equal to minus 0.049, and that total sum of total is minus 0.01. Therefore, the traverse is adjusted by making use of third rule. Hello friends, I am RM Gurud, working as Assistant Professor in Civil Institute of Technology, College of Engineering. This is module number 5 of surveying. In this video lecture, we have seen what is conjugative coordinate, how they are to be calculated. That is, latitude is calculated as L cos theta, departure is calculated as L sin theta, where L is length of line and theta is reduced bearing of line. And depending upon the line in which it is going to fall, we are going to provide a sign for latitude and departure. Similarly, we are going to produce the Gell's table so that whatever the closed tower is to be fitted in the first quadrant, so that we are going to eliminate the value of closing error. Thank you.